Hello. For today's lesson, I'm going to be talking about the basics of photographic exposure. To begin with, I want to talk about the fact that regardless of whether or not you're using an older film camera or a more modern digital camera, the basics of photographic exposure are identical. There are three basic exposure controls used in photography. The first one is the ISO sensitivity. The second one is the aperture, and the third is the shutter speed. These combine to form what is known as the exposure triangle. To demonstrate what these different features are, I'm going to set these cameras down. And what we're going to talk about first is ISO sensitivity. So I am using some orange liquid to simulate the idea of sun, and this idea that we have an ISO scale that ranges typically from 25 all the way up to 3200. Now as you look at an ISO scale, you will see that every third number on the ISO scale is exactly double the previous number. And what this refers to is the exposure unit that we use and commonly call a f-stop. And what that really means is the factor of 2. With each of those numbers that are doubling or cut in half, we are either increasing or decreasing the sensitivity by half or double. So on the ISO scale, we have what's known as a 1/3 stop scale, meaning that the numbers in between are increments of 1/3 of an f-stop sensitivity. Now, as I take and pour light into this container, you're going to notice something, and that is, as we get up to the first number there, ISO 3200, I don't have very much light energy, and that's because that's considered a high-speed sensitivity. So the higher the number, the less amount of light necessary to form a proper exposure. Now, proper exposure, when we talk about camera exposure, is the amount of light necessary to produce a middle gray value. In fact, this is a gray card, a rather beat up gray card, but nonetheless, this is what exposure is calibrated to take however much amount of light is being exposed and to convert it to a middle gray value, an 18% reflective gray value. So when we say the ISO is calibrated for ISO 3200, we're setting our camera ISO to be calibrated to the amount of light, this little bit of light that's necessary to produce a middle gray value. Now I'm going to add some more light, and what you'll notice is the lower the number, the more light that it takes. So here we're up to ISO 200, get up there a little bit further, and you'll notice there's a lot more light necessary at 200 than 3200. So for this demonstration, we're going to start out with a basic exposure amount, and what we're going to do is, you'll notice that on the aperture scale, the smaller the number, the more the light that's being let in. And that's because the aperture represents a fraction. So when I get up to the top here at f2.8, that really represents the diameter of the opening of the aperture is equal to 1/2.8 as compared to the focal length of the lens. So if I have a large aperture, I have very little left over for a shutter speed, just a little bit of light shutter speed there. The larger the aperture, the faster the shutter speed. But now if I stop the aperture down, I'm reducing the amount of light, and then I need to slow the shutter down in order to allow more light in. What I'm doing is I'm creating what's known as an equivalent exposure. Photography works on a reciprocal relationship. If I decrease the amount of light, I have to increase the shutter speed. If I decrease the shutter speed, I have to increase the aperture by going to a smaller number. And virtually everything in photography is backwards. You want to think about things as fractions. You want to think about opposite of what you might think. Instead of the larger number letting in more light, it's actually the smaller number lets in more light. And same with the shutter speed. The faster the shutter speed, the larger the denominator is. The smaller the shutter speed, or the slower the shutter speed, the smaller the number. So this is a simple demonstration to show you that you have equal relationship between shutter and aperture in 1 f-stop increments. So what I have here is a chart that visually shows you that as we go to smaller numbers on the aperture, we have a wider opening. The typical widest aperture on the most expensive lenses that you'll typically see on the market is f1.4, and then we go down half the amount of light to f2, half the amount of light again to f2.8. Don't worry about these numbers yet. I'll explain the mathematical formula where that comes from. But if you'll notice, as photographers, we're not particularly good at math, nor are we very interested in math. We're interested in how things appear. So don't worry about the math part right now. What I want you to notice is 1, 4, 2, 2.8, 4, 5.6, 8, and 11. You'll notice the larger the number, the smaller the opening, which means it's letting in half as much light each direction. Or if I move up from the larger number to the smaller number, I'm actually adding twice as much light with each of these. Now let's go over here to the shutter speed. We have a 1 second exposure, and most of the time when we refer to 1 second exposure, that's the slowest exposure we can have with knowing that we will get a full reciprocal relationship on exposures, and I'll talk more about that later. But generally, if you go slower than 1 second, the sensitivity will not be uniform, and you'll have to add what's known as a reciprocity factor. You'll have to add a little more time. That's a whole different lesson. We don't need to worry about that. But here we go, half a second, half as much time. Quarter a second is half again as much time. An eighth of a second, half again. Now, this is where we find photographers aren't very good with math, because guess what? We go to a 15th of a second when you'd expect it to be a 16th of a second. I suspect this was due to the mechanical nature of early shutters that were using gears and springs, and when they were trying to be as accurate as possible, they probably just came up to a 15th of a second. You'll see some old shutters that will, instead of having an eighth of a second, it'll be a 10th of a second. But if you're using a modern SLR or digital SLR camera, those shutter speeds are going to be very accurate with the electronic shutter mechanism. But anyway, we go from 1 to a half to a quarter to an eighth, 15th, 30th, 60th, 125th, and so on. And you just have to memorize this. This is the basics of photography, exposure scales, and it's like learning your scales to play music. If you don't know how to play the key of C on a scale and make octaves and make chords, major and minor, you can't play music. Well, the same with photography. We need to know what these basic exposure scales are for both the aperture and the shutter speed, and these are the standard full f-stop increments that have been used in photography since the beginning. Your camera may have different settings in between, and those typically refer to a 1/3 stop increment. I'm not going to worry about that today. We just need to know the standard full stop scale, because here's the magic of photography and exposure. If I take any of these combinations here, for example, I'll start at f8 at a 60th of a second. There's an old adage in photography, f8 and be there. It's the most, it's the middle aperture. It gives you the optimum sharpness on a lens, and it generally gives you a shutter speed that is fast enough for handheld photography. So photojournalists typically used to say f8 and be there. So here we have an exposure of f8 at a 60th of a second. Well, that is the same net exposure as if I were to go to f5.6, I'd add twice as much light, and I would stop the shutter speed down in half to get the same exposure. So here's f8 as a 60th is the same exposure as f5.6 at 125th. Or if I go the other way, 1/30th of a second, I've slowed the shutter down to allow twice as much light. Well, now I'll need to adjust my aperture one stop less at f11. That's how I get an equivalent exposure, because each of these exposure controls impact the aesthetics of what my image will look like. Shutter speed will control movement in the frame, how motion is recorded, whether it's a motion blur or a stop action image, and aperture will control the depth of field, which is the appearance of sharpness from foreground to background. There we go. Okay, so I'm virtually wide open. I'm at f2 at 4,000th of a second, and I'm going to make a series of exposures that are equivalent. They're all going to be based on f2 at 4,000th of a second. So I'm going to come in here and make my first exposure. Then I'm going to stop the lens down to f2.8, and that's going to make me cut the shutter speed down in half to 2,000 to get the equivalent exposure. And now I'm going to stop down to f4, and I have to then slow the shutter speed by opening up a stop plus one stop to 1,000th. And then I'm going to go down to 5.6, and I have to cut my exposure time or slow it down in half to make the same exposure. And I'm going to go through another sequence here, f8 at 2/50th, f11 at 1/25th, f16 at 60th, and that's as far as that lens goes. And what we're going to see is a series of images that have the same overall exposure but a completely different aesthetic experience because of the change in depth of field. Remember, the smaller the aperture, the larger the number means the smaller the aperture, the greater depth of what appears to be in sharp focus to us. And so for this particular image, I think having a shallow depth of field by having the image, the lens opened wide, gives me a more pleasing effect than having too much detail. Having the aperture open wider with less depth of field throws the background out of focus, and it's less of a distraction. There is such a thing as having too much sharpness, too much detail, and so I find with close-up photography I really like to have a wide aperture with a fast shutter speed.